Hello guys, now we have to solve the equation number 5. In the expression p is equal to a square by b into exponential power ax minus of ax. Here p is pressure, x is distance and a, b are constants. Find the dimensional formula for the b. So we have to note down the point here. Exponential functions are dimensionless. So therefore the exponents are also dimensionless. So we have to find a solution. The value of a square by b is equal to p, because in this equation number 1, this given equation, we have to apply the according to principle of homogeneity. There is a square by b is equal to value of dimension of p. So we know that p is the pressure, and so a square by b is equal to, if we have to find the value of b, then we can write it as a square upon b. Then b is equal to, the value of b is equal to a square by p. Here in the equation, the value of exponential is e power minus of ax. So the as we note down that the exponent function always are dimensionless. So a is equal to, a having the dimension is equal to l minus 1. If we put the value of a and value of p in this equation number 2, then we find that b is equal to a square by p, that is equal to l inverse power 2 upon m l minus 1 t minus 2. The final value we get m minus 1 l minus 1 t 2. This is our answer. Thank you. Here we talk about example number 6. In the expression L is equal to A plus bx by ct, where L is magnitude of angular momentum, x is length, t is time, and a, b, c are constants. The dimension of a by c are the same as those of. We have to find the dimension of a by c, which equation is equal to the dimension of a by c. So torque, work, moment of inertia, and impulse. Firstly, we talk about these equations, dimension equations of these physical quantities. Let us talk about these dimensions, these equations of dimensions. If we talk about the torque, dimension of torque, that is equal to m1 L2 t minus 2. This is the dimension of equation of torque. And moment of inertia, moment of inertia is equal to ml2 t0. And the next one is work. As we know that work and energy having the same expression for dimensional formula, and that is equal to m1 l2 t minus 2. And the value of impulse having the value m l1 t minus 1, and the value of so now in the expression, according to expression, we find out the solution. Here the given equation is L is equal to A plus bx upon ct. We can write it as A by ct plus bx upon ct, that is equal to L. L is magnitude of angular momentum, and we have to find this A by C. So here we know that this according to principle of homogeneity, A by ct is equal to dimension of L. So A by C is equal to L into T, that is equal to, here L is magnitude of angular momentum, and angular momentum is equal to mass into velocity into distance into time t. This is the formula of angular momentum. So here the dimension of mvr is m, mass having the m, v is velocity, that is lt minus 1, and r is work as we can say it is distance, and so this is L, and time is t. So when we solve it, then we find the m L2 t 0. This is the m L2 t 0. We find out the value for A by C. So how we can correlate it, like if we check out these values, torque having the time t minus 2, and moment of inertia having t0. So here is the same value as moment of inertia. We can say that the answer is B. Thank you. Now we will talk about example number 7. Einstein's photoelectric equation is K max is equal to h nu minus W naught, where K max is maximum kinetic energy of photoelectrons, nu is the frequency of incident radiation, and W naught is work function of metal, and h is Planck constant. To find out the dimension formula for h and W naught. So for this, we already know the dimension of h nu is and the dimension of W naught are same, those of K maximum. So here we find out h nu. So h nu is equal to K max, and we can write it here. H is equal to, the dimension of h is equal to K max upon nu. So K max is the energy, like it having the kinetic energy, so we can write it as the dimension of energy is equal to K max. So here dimension of energy we already talk about it, ml2 t minus 2, and nu is that is inverse of time, so we can write it as t minus 1, and here t minus 1. So after solving, we find out m L2 t minus 1, the dimension of Planck constant, and this is our first answer. And the second one is, we know that here already know that the dimension of h nu is equal to K max, and here according to principle of homogeneity, W naught is also K max. So W naught is equal to K max, where K max is the form of energy. So ml2 t minus 2, this is our the dimensional formula for work function of metal. Thank you.